Well, hello, fifth grade mathematicians. Today we're going to take a look at entry task day 106. So today I'm actually outside, so you might hear some birds and lawnmowers and cars and things like that, but it's such a beautiful day, I just thought I'd do this outside. So let's take a look at problem number 1. Use this rectangle to solve the problem. Enter the area in square centimeters of the rectangle. Well, the first thing we know is that when we find the area of a rectangle, that we will multiply the length times width. And it doesn't really matter what the dimensions are, we will just follow that rule. So as we look at the length, it is 9/10 centimeters times 6/8 centimeters. And that would equal 9 times 6 over 10 times 8. And then we're also multiplying the centimeters times the centimeters, which we'll get to a little bit. I'll explain a little bit more later. So the way I'm going to solve this is I'm going to cross cancel, and I'm looking for factors that the numerators and denominators have in common. Well, I know that 2 goes into 6, and 2 also goes into 8 and 10, but I'm just going to choose one of them right now. I'm going to choose 6 and 8. So 2 goes into 6 3 times, and 2 goes into 8 4 times. Now, there are no other factors that we can simplify, so we're just going to do 9 times 3, which is 27, and 10 times 4, which is 40. And then, when we do centimeters times centimeters, anytime you multiply one factor by another factor that is exactly the same, we would square it. So centimeters times centimeters is centimeters squared, which you already knew because this was area. So as we go over to fill in our answer, the area of this rectangle is 27/40 centimeters squared. Now, if I just was to estimate this, okay, well, I know 9/10 is close to 1. And I know that 6/8, if we rounded to the nearest whole number, would also be 1. And we know that 1 times 1 is 1. And if we look at our answer, it's 27/40, which is, if we rounded that to the nearest whole number, it is closer to 1 than it is to 0. So that would make sense for us. Okay, let's erase our work here and take a look at problem number 2. Now, problem number 2, Jose is dividing gravel into equal-sized piles. Each pile contains 1/3 yards of gravel. How many piles can Jose make from 7 yards of gravel? Well, this is a division problem, and we know that because it says that Jose is dividing the gravel. And if we look here, we have to find the gravel, and the gravel specifically tells us that it is 7 yards. So I'm going to draw a tape diagram, as usual, because they are so helpful. And this whole tape diagram represents all of the gravel, 7 yards of gravel. Now what I'm going to do is I'm going to break this hole into 7 pieces. for 7 yards. Each piece would be 1 yard. So, and then what it tells us is that each pile contains 1/3 yard of gravel. So if one of these partitions here is 1 yard, we know that if we broke it into thirds, we have 3/3 in 1 yard. And if we have 3/3 in 1 yard, and I'm just going to write the number of thirds in each yard, we would have 21 yards. But let's set this up. This is a division problem, so we're taking 7 yards and we're dividing it by 1/3. And what we see is that 7 divided by 1/3 is the same as 7 times 3, because there are 3/3 in every one hole. So 7 times 3 would equal 21 piles. Each third represents a pile. So let's go over here and we will record our answer. 21 piles of gravel. Okay, on to problem number 3. So I'm going to get rid of my scratch pad there, and let's read problem number 3. And actually today I'm going to explain it a little bit differently than we've done in the past, just to give you another strategy. So, plot each point on the coordinate plane. We have 3 parts, part A, part B, part C. So we always know, just as in review, whenever we have coordinates, we start at the origin and we will always go over and then we will go up. However, we're going to take a look at this just a little bit differently, so we can definitely use that strategy, and that's the one that I often will use. But what I want to do is I want to talk about our coordinates. So we know that the x coordinate would be found on the x-axis, the numbers that I highlighted in green. And we know that the y-coordinate would be found along the y-axis, and that's what I have highlighted in yellow. Okay? So one way that we can think of these coordinates, for example, the coordinate 2, 1, it is 2, whoa, let me undo that, get my pencil. It is 2 spaces from the y-axis. So the y-axis is in yellow. And if my first point is 2 from the y-axis, it would be 2 over, right? Well, we already know that. And the y-coordinate, we can think of it as being 1 from the x-axis. So if we started on the x-axis down here and we were 1 from it, we would go up 1, right? So one way to think of this is being the x-coordinate is a number of spaces from the y-axis, And the y-coordinate is a number of spaces from the x-axis. And so, if I was 2 from the x-axis, I'd be right on this line. And if I was 1 from the I'm sorry, 2 from the y-axis, I would be on the blue line. And if I was 1 from the x-axis, I'd be on the green line. And what we see is where the points intersect would be our coordinate pair. So that would be part A. Okay, so let's do that again. Again, it's just a different way of looking at this and thinking about it. So for the next part, we are 3 from the y-axis, and I'm going to change to green here just to be consistent. We are 3 from the x-axis. So let's start with the 3 from the y-axis would be on that line there. And 3 from the x-axis would be on this line here. And where they intersect. Now, it might be kind of confusing because I have other lines in here as well. So let me erase the first one. But I want my point still. So that's A. And we have point B right there. So let me erase point. Okay. So again, there are multiple strategies that we can follow in solving a math problem. And this is just another way of looking at it. So for part C, we are 8 from the y-axis. And we are 7 from the x-axis, and wherever they meet, that's where our point is. So that would be part C. So anyway, just a different way of looking at things. If you have any questions, please reach out to your teacher. And the other thing I wanted to remind you all of is that sometimes when you have a lesson, you're being instructed in a particular method, and you should use that method. But in the real world, you're ultimately going to choose methods that you like or that fit the situation. And so I know as a teacher, one of my jobs is to just equip you with as many tools as necessary, because sometimes one tool is easier to use than another tool, and sometimes it really doesn't matter. You just choose your favorite. So anyway, just keep up the good work.